All right, folks. Hopefully you have watched the previous video where I derived the equations for getting to taking total station measurements and turning them into new elevations. If you haven't, I recommend you watch that first. Today, I'm actually going to be using those equations to calculate elevations at different points in a traverse. And the traverse example I am using is shown here. It is a traverse like the ones that you guys are doing in class. It starts on Centennial and it moves to new points. And as a reminder, whenever we are doing calculations in a traverse, we always want to use our foresight measurements. And so we are going to use those foresight measurements today. The only problem is we have to start by using a backsite, and this can sometimes add a little bit of confusion. So in this particular case, I want to bring us back to how to write that equation and then how we would apply that equation in this particular case. In this first example, the group is set up on TP1. They are set up on TP1. So I'm going to label this. They are set up on TP1, and they are backsiting the benchmark. They're backsiting the benchmark. As a reminder, we always start by writing equations where the instrument is located. So I'm going to write down elevation at point 1 is equal to, or elevation at point 1 plus the height of my instrument, plus, and this is just our sign convention, our vertical distance corresponding to our slope distance times the cosine of our vertical angle, gets us all the way over to the prism rod. And to get down to the ground, we subtract the height of the rod. And that will get us to elevation at the point where the prism is. So this is where the instrument is. And this is where the prism is. And the prism in this particular case is on the benchmark. So this equation as we have it written, we could solve, but what do we want to know? We want to know, or excuse me, not know, we want to find elevation at TP1, and our known here is elevation at the benchmark. It is Centennial, so we know what that elevation is. And I am happy to tell you that that elevation is 348.94. All right, so we want to rewrite this equation so that we have what we are solving for on the left, which is elevation 1, equal to what we know on the right, which is elevation at our benchmark minus HI, right? Because I'm moving this over to the other side, plus my vertical, excuse me, not plus my vertical distance, minus my vertical distance. Minus my vertical distance, again, move to the other side, and plus my rod height, again, I'm moving it to the other side of this equation. And I'm going to write this a little more fully. I'm going to say elevation at BM minus HI minus SD cos VA. Check out the previous video if you want to see how we get to those points. And now I can actually just enter values from that particular reading. Elevation at the benchmark, 348.94. Minus HI up here, it's 4.77, plus HR is 4.80, minus SD is 200.706, times cosine, sorry, I'm going to have to squeeze this on there, 87 plus 49 over 60 plus 44 over 3,600. Ooh, I squeezed it on there. And if you do this math, you should get a value of 341.37 feet. So that is the elevation at TP1. What about the elevation at TP2? Now things are a little bit different. To find the elevation at TP2, again, let's do a drawing. Our total station is set up on TP1. And in this particular case, we are foresighting to TP2. And again, we always want to write our equation with the instrument on the left. Instrument, I swear I can spell, on the left, where we have elevation at 1, because that is where the instrument is, plus the height of our instrument, plus our vertical distance, minus HR equals elevation where our prism is, which is elevation at point 2. Do we need to move this equation around at all? Hopefully you're thinking to yourself, no, we don't need to move that equation around at all. And you would be correct. So let's put some numbers in here. Elevation at point 1. We just found that from the previous equation. So elevation at point 1, we just found is 341.37 feet. And actually, I'm going to get rid of the units from there just to make it a little bit easier. And I'm going to say 341.37. I am taking stuff from this line, the foresight to TP2, 341.37 plus my instrument height, again, is 4.77. My vertical distance is going to be my slope distance, 266.274, times cosine of my vertical angle, 86 plus 51 over 60 plus 47 over 3600, minus my rod height, which is 4.80. And if you do this, you will find that elevation at point 2, or TP2, is equal to 355.91 feet. You can continue to use this same equation, right? Because we're using foresights now. Continue to use the same equation to calculate the location at TP3 based on these measurements, the location at TP4 based on these measurements, TP5 based on these measurements, and TP6 based on these measurements. And finally, you're going to want to use that last set of measurements, the foresight to TP2, to get back to TP2 in that traverse. And what you will be able to do eventually is to determine your vertical misclosure, which is the difference between elevation 2 from foresight at TP1 minus elevation 2 from the foresight at TP6. Essentially, you can think of this as the elevation before you traverse, and this is the elevation at the end of your traverse. And that difference will tell us our vertical misclosure. All right, guys, I hope this helps. Please come see me if you have questions.